We did this handout in class to prepare for a quiz on block day. First, we used the periodic table to see if an ionic bond forms or a covalent bond forms. An ionic bond forms between a metal and a nonmetal, or an atom on the left side of the staircase with the right side of the staircase. A covalent bond forms between two nonmetals, or two compounds to the right of this staircase all the way to the halogens, but not including the noble gases. Then we use the periodic table to draw Lewis dots. Remember, we always write the least then the most electronegative atom. Atoms in an ionic compound steal and give valence electrons. So here, potassium gives and phosphorus steals. Now, each atom needs 8 valence electrons for stability, or 0 or 2 if the atom is hydrogen. So to get 8 electrons, phosphorus has to steal from 3 potassiums. Then we can use the naming protocols on page 33 and 34 to name the compound. So it is K3P, or potassium phosphide. Now let's look at a covalent compound. Atoms in a covalent compound share their valence electrons. Each atom counts the shared electrons as its own. So after this first share, oxygen is full, but silicon needs 2 more electrons. Therefore, the compound requires another oxygen. When we name a covalent compound, we include a prefix when there's more than one atom involved. So this compound is silicon dioxide. Look at page 35 again if you forgot how to do this. Now, cesium gives 1 to iodine. We can also look at ions on the periodic table. It takes 1 positive 1 ion to balance 1 negative 1 ion. Or in the first example, it took 3 positive 1 ions to balance 1 negative 3 ion. In this case, we have cesium iodide, and on the final one, we have magnesium sulfide, because magnesium gives 2 and sulfur steals 2. A drawing that shows the movement of electrons during compound formation is called a reaction mechanism. And yes, those are parakeets in the background of this audio recording.